Hello ladies and gentlemen, welcome again to another lecture. In this lecture we're going to review the merge sort algorithm. Now the merge sort algorithm is a recursive algorithm in nature, and we're going to see why. Well, the idea basically is that if you have an array with some bunch of random numbers that are not ordered, 3, 1, 4, 6, 7, 1, 2, 2. So to sort this array, you can think of this array as two arrays. So you can divide this array into two subarrays, and then you keep dividing those subarrays into two subarrays, and so on until you get arrays of size 1. And by definition, an array of size 1 is already sorted, so we start merging them together to get the final sorted array. So this technique is called divide and conquer. So we divide the original problem into smaller subproblems, and we solve every subproblem individually, and then we combine the results together. So for instance, from this array we would get these two arrays. So let's divide from 0 up to, so 0 plus 8, that's 8 divided by 2, so that's 4. So from 0 to 4, so we're going to take this first part, and this is our second part. Okay, so we get these two arrays. So we have 5 elements here. So minus 1, 3, 1, 4, 6, and another array here with 4 elements. So we have here 7, 1, 2, 2. The same thing happens to these subarrays here. So we divide this array, this smaller array, into two subarrays of smaller size. So we have here minus 1, 3, 1, and here we have 4 and 6. Same thing with this subarray, so we have 7 and 1, and 2 and 2. Same thing here, so we have two subarrays. The first one has 2 elements, minus 1 and 3, and the other one has 1. And finally we have here 2 arrays, one that has minus 1 and the other has minus 3. From here we have 2 subarrays, and so on. So I think you got the idea. So we keep dividing until we get a very small bunch of small arrays of size 1. So this 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are small, very small arrays. And now after we made all of these divisions, we're going to combine these arrays together. Okay, we know that every one of these arrays is sorted. So this first one is sorted because it has one element. The other one is sorted, sorted, sorted. Every array, by definition, every array that has only one element, it is by definition sorted. Cool. Now let's suppose that we have two sorted arrays. Okay, so the first one having 1, 2, 5. The other one have, for example, it has minus 1, 4, 7. And we want to combine these two arrays together to get an array of size 6. It has 6 elements, but they're sorted. Okay, how can we combine these two sorted arrays into one sorted array? So to do this, let's create an array that has 6 elements. And we're going to follow the following algorithm. So we're going to create a pointer k here that points to the very first element, and 2 other pointers, pointer I and a pointer j here. Okay, so pointer I points to the beginning of the first array, and pointer j points to the beginning of the second array, and pointer k points at the beginning of the result array. And we keep doing the following operation. We compare the element that I is pointing at. Okay, so we compare this element with the element that j is pointing at. And we pick the one that is smaller. So the smaller one is minus 1. Okay, so we copy minus 1 into the array. So minus 1 here. And then we increment the j counter. So j becomes pointing at the second element. And we keep doing that again. So the element that I is pointing at versus the element that j is pointing at. Now the element that I is pointing out pointing at, which is 1, is smaller than the element that j is pointing out, which is 4. 1 is less than 4. So we copy 1 over. And then we increment I. So I now points at the second element. We keep doing that. So 2 versus 4. 2 is less than 4, so we copy the 2. Okay? And we increment the i's pointer. Now I points at the third element. Now we keep doing the same thing. Now 5 versus 4. Now 4 is less. So we copy the 4 and we increment the j pointer. Okay? Now 5 versus 7. 5 is less than 7. So we copy the 5. And we increment I. Now I points outside of the array, right? So for the next comparison, we're just going to copy the rest of the elements of j. So just going to copy j. So let's copy j. So basically that's the algorithm. We create 2 pointers, I and j. I points at the beginning of the first array, the first sorted array, and j points at the beginning of the first sorted array, the second sorted array, sorry. And then we have k pointing at the beginning of the result array. And basically we keep comparing t of I with t of j, and whoever is smaller, we copy that into result of k. And of course, every time we copy something into k, we increment k. So that next time we copy to the cell that is adjacent next to it, okay? We don't overwrite the element that we just copied so far. Now after completing this, we would have k pointing here, okay? So k basically contains the size of the array. It contains how many elements we have, okay? So for our merge algorithm, so this is basically a basic merge algorithm. Okay, so this is a merge algorithm. It takes 2 arrays, array 1 and array 2, and it merges them together to create a result array. Now, for the merge sort algorithm, the input array will always, the first half of the array, so this is the first half, and this is the second half. The first half will be considered the first array, the first sorted array, okay? So this first sorted array is this one. So actually I points here. This is I. And the second sorted array is the second half of the original array. So j points here. And we know, of course, the middle of the array. So I starts from the beginning up till m, and then j starts from m plus 1 up to the end of the array. So this is the beginning of the array, and this is the index of the end of the array. So working at the same array and not very different, distinct arrays makes the algorithm that we're writing more efficient, because we have to deal with just one array, okay? And of course one temporary array which will contain the result. So basically we take the original array, this one here, this array, we divide it by 2, and then we get the first left part sorted, and then we sort the second part, and then we merge them together to get the original, to get the array back sorted. How are we going to do that? So we're going to merge the array inside a result temporary array, and then we're going to copy the result back to the original indices. All right, so let's apply this idea into our diagram at the left. So we have here -1 and 3 are sorted. So -1 is sorted and 3 is sorted. We're going to merge them together. So we have basically 2 arrays, one that has -1 and the other that has 3. So we're going to build an array of size 2 from them. We have I points here and j points here, so I is less. So we're going to copy -1 here and 3 here. So we've got our sorted array. So this one, so these 2 subarrays are sorted to create the original array. And we're going to do the same thing with these 2 arrays. So we're going to merge the left array with the right array. And after merging them, we're going to get -1, 1, and 3. So that's -1, 1, and 3. Now we have our left array sorted. So we're going to sort our right array. And the same thing here, we have 4 sorted, 6 sorted, we combine them together, and then we have this array sorted. And now we're going to combine these 2 arrays together to get a bigger sorted array. So we have -1, and then we have 1, and then we have 3, and then we have 4 and 6. Now this array is sorted. Now we need to sort the right subarray, this one. So this one we'll call subproblems, which in turn will call their subproblems. Their subproblems are sorted, 1 and 7. 1 is sorted and 7 is sorted. So when we merge them together, we would get them reversed. So 1, 7. So now we have a sorted array at the left, and then now we're gonna sort the right subarray, 2 and 2. The subarray will be divided into 2 halves. So we have an array of size 1 that has 1 element, 2 sorted, another one sorted. We combine them together to get another array that is sorted. Now we're gonna combine these 2 subarrays together to get the elements 1, so that's 1, and then we have 2, so that's 2, and then we have 2, another 2, and then we have 7. So this one is 7. So we get an array that has 1, 2, 2, 7. Now we have these 2 arrays are sorted, so we combine them together to get a bigger sorted array. So we have -1, and then we have 1, so that's 1, and then we have another 1, so that's 1, and then we have 2, so that's 2, another 2, so that's 2, and then we have 4, we have 3, so that's 3, and then we have 4, and that's 4, and then we have 6, so that's 6, and then we have 7, that's 7. And finally we got our array sorted, so -1, 1, 1, 2, 2, 3, 4, 6, 7. So let's review. So we said that if we have an array that is not sorted, then we can keep dividing the array into 2 chunks, and every subarray will also be divided into 2 subchunks, and so on and so forth, until we get very, very small arrays of size 1. And by definition, an array of size 1 is sorted, and we start merging them together because thankfully we have a function that allows us to merge 2 subarrays. That will allow us to merge 2 subarrays that are already sorted, and these subarrays happens to be adjacent. So sending the beginning and the end of the bigger array is just sufficient. All right, so now so this is the basic idea. So let's just write an algorithm that implement this idea in pseudocode. Okay. So let's delete this, and